Alright, before we start actually measuring things, we need to be able to calculate and figure out scales and know the correct way to round our measurements. So basically set up two rules. One is basically figuring out scales. So, if you see right here, there's two rules to figure out a scale. You're going to subtract the two numbers you know for sure, and then you simply divide by the number of tick marks. So, for example, let's say I put a 10 here and a 20 here, and this is some sort of measuring device. Well, what you would do is you would say, well, I know the 10 and the 20. You're going to subtract those two numbers. So you subtract them, and usually take the biggest one minus the smallest one. So it would be 20 minus 10 is equal to 10. And I just figured out A, it's 10. Then you're going to divide by the number of tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. So you divide by the number of tick marks. 10 divided by 10 tells you have a scale of 1. In other words, you're counting by ones. So this would be an 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay. Let's try another one. Let's say you have 5 here and 6 here. What's the scale? Well, let's use the same method. Subtract the two numbers you know for sure. You know you have a 5, you know you have a 6. 6 minus 5 is equal to 1. So I just did part A. Divide by the number of tick marks. There's still 10 tick marks, so I'm going to divide by 10. On any number, of course, you know that there's an unwritten decimal at the end of the 1. So when you divide by 10, you just simply move the decimal one place over, and you get 0.1. So you're measuring by 0.1s. 5.1, 5.2, 5.3, 4, 5, 5.6, 5.7, 5.8, 5.9. And that tells you actually this is supposed to be 6.0, and that's supposed to be 5.0. Alright, so that's how you figure out scale. Next, how do we round our measurements? So let's come up with a scale again. How about we do, let's just start with a simple scale. We'll do 20 here and 30 here. And you can, again, either guess and check, or you can use this method. And either way, you're going to figure out that we're counting by 1. So this would be 21, 22, 23, 24, 25, 26, 27. I'll stop there. Okay. What if I said to you, what is this measurement right here that I'm pointing at? The way you go about answering this is as follows. You say, okay, I know that I've at least made it to the 21. So we should all agree that the correct answer is 21. Now, you'll notice that this instrument is measuring whole numbers. And what you do in science is you always imagine that there are 10 additional tick marks, and you measure to that spot. So since this measures to whole numbers, you're going to pretend, and I'll put them in a light gray, you pretend that there are 10 additional tick marks there. I don't know if there's actually 10, I'm estimating. And you would estimate to that tick mark. So it looks to me like that is about 21.5. 21.4 would work. 21.6 might work as well. Those would be reasonable answers. All right, let's try another one. So let's see here. Let's say you have 10 here, 11 here. Oops, that's not an 11. 11. Figure out the scale. Difference between the two numbers is 1 divided by 10 tick marks equals 0.1. So we're counting by 0.1. So for example, this would be 10.1, 10.2, 10.3, etc. So now, what if I pointed to right here? How would I record that answer? So, first of all, we note that this instrument is measuring one place past the decimal, or to the 10th spot, which means we're going to make up an estimate for the 100th spot when we measure. So for example, we could look at this and agree that we all know it goes to at least 10.2. 10.2 should be undebated. However, you are going to, and I'll use light gray again, pretend that there are 10 additional tick marks in between the known ones, and you would estimate where it is based on that, and that looks like about 10.24. We should all agree on the blue, and on the gray we could disagree. And this should be measured always to the hundredths on a ruler or a measuring device that looks like that. Now, what happens if we land, for example, right on the tick mark? So let's say I measure something and it lands right here. The correct way to read that would be 10.1, but we're supposed to estimate the hundredth spot. Since it's exactly on the tick mark, we would add a 0 here, showing that we estimated that spot, so 10.10. Alright, let's try one more. What if I have a scale that starts at a 15, goes to 20? These are a little harder. So first of all, I got to figure out the scale. So there's a difference of 5 there, divided by 10 tick marks again. Means I'm counting by 0.5s this time. So for example, this would be 15.5. This would be 16.0. This would be 16.5. This would be 17.0. This would be 17.5, etc. Now, you'll notice again, they're all being measured one place past the decimal or tenths, so technically this is 15.0. Okay? So this instrument measures one place past the decimal or tenths, which means we're always going to record our answer to hundredths. So let's say we were measuring something and we get about, right about here. How would I record the answer to that? Well, again, you would make up 10 additional tick marks. And you wouldn't write them in on a real instrument. I'm just trying to illustrate the point. So, just using common sense, what's between 17.0 and 17.5? Well, somewhere between 17.2 and 17.3 would be this area right here. It looks like it's about exactly in the middle to me, so I would call this 17.25. This we should pretty much agree on. This one is an estimate. Okay? So again, it would look something like that. So I hope that helps with scale. And then we use this whenever we measure something. You always look at the instrument, figure out the two numbers you know, figure out what it's counting by, and measure to the correct decimal place.